Welcome to another session of Circuits and Networks. In today's class, we are going to see the problems which were asked in previous IIT exams, especially IIT Guwahati, because you all know that this time in GATE 2026, IIT Guwahati is going to prepare the paper. So we'll look into the basic type of problems which are asked in Circuits and Networks. So you can see here a GATE 2010 and GATE 2018, the problems were focused on these kind of problems. So we'll solve all the problems one by one. We can see with the first problem where you have source connected to a resistance 1 ohm. And what is given in the problem? The resistance is connected across a source that has a load line of V plus I equal to 100. The current through the resistance is, you have to get the value, that is the numerical value. For that, the options were given as 25 amperes, 50 amperes, 100 amperes and 200 amperes. This was asked in GATE 2010 for 1 mark problem. So for this, you can go into the figure and you can look into the figure where you have uh, minus V plus 1 into I equal to 0. We are applying KVL to this loop, which is having a source connected to a resistor. With this, I'll get the value of V, which is equal to I. So here the source voltage is equal to the current flowing through the resistance. That is the first catch. Then the given information in the problem, that is V plus I is equal to 100. So let us mark this as equation 2. With these two equations, we can get the value of V, which is equal to 50. In fact, I is equal to 50 amperes. So option B is the right answer. Now you go for the second problem where you can see the same year 2010, it was asked for 1 mark. The switch in the circuit has been closed for a long time. Okay, it is opened at t equal to 0. At t equal to 0 plus the current through the 1 microfarad capacitor. For this, the options were given as ABCDs, and we'll start with the solution, assuming that at t equal to 0 minus, the switch was closed and steady state conditions have reached. Because you can see the position of the switch, it was closed before, right? If that is true, for the closed condition, this is a circuit what we can figure out from the given circuit. You can see you have a 5 volts, 1 ohm resistance, capacitor acts as open circuit, and current flows through the resistor 4 ohms, in fact in series with 1 ohm. So when the current you're going to calculate, you're going to get the value of current and well as the voltage. In fact, why we are calculating voltage? Because we know that is the source voltage. So with the help of voltage division rule, we can calculate the value of voltage, which is equal to 4 volts. Okay. Now, for t equal to 0 plus, the charged capacitor acts as a voltage source and drive the 4 ohm resistor. If that is true, from the given circuit, you can imagine the capacitor 1 microfarad is charged to 4 volts and it is driving the resistance 4 ohms. So the voltage across capacitor, in fact the voltage across the resistance 4 ohms, it would be calculating, that is the 4 by 4, that is a voltage by resistance, which is equal to 1 ampere. So option B is the right answer. Then in third question you can see, which is in the same year GATE 2010, which is for 2 marks. If the 12 ohm resistor draws a current of 1 ampere, the value of resistance R is. It is a good question. Now applying KCL at node V. So how to do this? I'm identifying a node V because node is a point where all the branches are connected. So all these branches are connected to a common high point, that is the voltage V. And why I'm going to apply, I'm going to see that the current which is incoming and outgoing, that is 2 amperes is incoming, 1 ampere is outgoing, and X, let us take the value of X is the outgoing, the value of current. With that, I'm going to get the value of X as 1 ampere. Once the current we have obtained, which is flowing through resistor in series with 6 volts, we are going to apply KVL in the loop as shown. You can see I'm applying loop over here like this. Already based upon the direction of the currents, the voltage drops are estimated, which is shown by plus and minus sign symbol like this. So with this, you're going to get the value of a resistor as 6 ohms. Quite important, and it is easy to understand the concept. Now you can see in GATE 2018, which is asked for 2 marks, which was prepared by IIT Guwahati, we need to calculate the equivalent impedance. If at all you look into this particular network, the resistor in the form of reactance, that is in the ohms impedance, are shown with the values as shown, and the options are given as ABCD. So what we are going to do, we are going to replace the repeated network with the actual network, that is nothing but Z equivalent. So Z equivalent is repeated by the common parameters which are framed in a kind of series combination. So this this network can be changed to this circuit with the help of the given information. With this, I can calculate the Z equivalent, which is nothing but the parallel combination of these two parameters in series with 9J ohm. So if at all you equate on the LHS and RHS, you're going to get the value of Z in the form of quadratic equation, that is nothing but uh, 12 J ohms, or you're going to get the value as minus 3 J ohms. So from the given option, the option is A. I hope you understand these calculations. It's simple. Just you concentrate on the equations and just go for a normal mathematical equation approach, and you get the answer as 12 J ohms. Then in the next problem, you can see it was asked in the GATE 2018. As a two-port network, we need to calculate the parameter H11, and the value of H11 is already given as V1 by I1, and it is kept at V2 equal to 0 ohms. Remember friends, already H parameters, we are going to obtain H11 as V1 by I1 by keeping V2 equal to 0 only. So that these are no new information given in the problem. That everyone should know how to calculate the H parameters. So we'll approach with the first method. Let us assume two loop currents I1, I2 as shown here. So you can see I1 is in clockwise, I2 is in anti-clockwise, and applying the KVL in the loops, and I'm going to get first equation as 2i plus I2 equal to V1, and second equation as 3i1 plus 2i2 equal to V2. So from this I can frame a Z parameters, which is nothing but 2132. It's a standard approach. With this I can calculate directly H parameters with the help of formula 1 by Z22 of a matrix delta Z, Z12 minus Z21 and 1. Now this is a direct formula to convert Z parameters into H parameters. And if at all you apply the formula, you're going to get the value of H11, which is equal to 1 by 2 ohms. It's a very easiest approach. If you are not good at this approach, then directly go with the H parameters calculations. So we are going to discuss method 2, where we can short this output terminal, and we can apply the KVL, and with I1, I2, you are going to get the H parameters, the standard formula in this form, and this is the original formula. And when you make V2 equal to 0, you are left out with V1 equal to H11 I1, and I2 is equal to H21 I1. Okay, if at all you want to calculate H11, this is the standard notation, and H21, this is the standard notation. Anyhow, we are applying the KVL, and we are going to determine the values of equation 3 and 4 in terms of H1 parameters, which is equal to 1 by 2 ohms. In fact, you can calculate the value of H21, which is also equal to minus 3 by 2. Now I2 by I1, it's a gain calculation. That's why you don't have any units. This thing you keep in your mind. Now if at all you go with the other approach, that is we are making the other parameter, that is current, equivalent to 0, that is the input current, then you are going to get V1 in terms of V2, I2 in terms of V2. Hence we are going to get the value of H12 and H22, and from the loop equation we are going to get 5 and 6 in this fashion, and H1 to H22 we are going to get the value as 1 by 2 and 1 by 2 respectively. So with this H parameters are obtained to be 1 by 2, 1 by 2, 3 by 2 and 1 by 2. So H11 value is 1 by 2 ohms. So that's all for today's class. So whatever the problems we have discussed, these problems were uh, asked by IIT Guwahati in the past years. So what I can suggest you people that you can select all the papers which were conducted by IIT Guwahati in the past years in every subject and prepare a notes, and you can prepare for GATE 2026 exam. That's all for today's class. I hope you like this video. Please share among your friends, subscribe to this channel, and please press the bell icon for the